Hey there, students. Let's have a quick video here to show how to do a problem from Chapter 9. So I've chosen homework number 12, which is on sections 1 through 3 of Chapter 9, problem 21, just something in the middle. And so if we look at the problem here, it says data on the weights of the contents of cans of diet soda versus the contents of cans of the regular version of the soda is summarized to the right. And there's a little table, and it shows the diet soda results and the regular soda results. Assume that the two samples are independent simple random samples selected from normally distributed populations. And we can see that it shows the mean value from sample 1, which is x bar, the standard deviation from sample 1 and from sample 2, that there were 24 cans in each of the samples, and that this is a test about the mean value of the populations of these two groups. So it says, do not assume that the population standard deviations are equal. So we're going to work with the standard deviations from the samples. And it says complete parts A and B below and use a 0.01 significance level for both parts. Okay, so what does part A ask us to begin by doing? Test the claim that the contents of cans of diet soda have weights with a mean that is less than the mean for the regular soda. So we're testing that on average, diet soda cans, the contents weigh less than regular soda cans. We can see in our sample that the mean value was a little bit lower. But again, our goal is to see if that is sufficient significant evidence in support of the claim that in general the average of all diet soda contents will be less. So we're going to set up a null and alternative hypotheses here. And so the question is, what are the null and the alternative hypotheses? And so the null hypothesis would be that our suspicion is incorrect. That instead of the diet soda cans being less, that actually they're the same on average. So so we would choose to have a null hypothesis that the average of the first sample population diet is equal to the second population, which is regular. And those choices are available in A and B, and in C, only D has something different. And so then the alternative to that is that what we're testing is true, which is that the diet soda cans weigh less, which would mean that the mu1 on average is less than mu2. And that choice looks like is given in C. In A, it's bigger, and that they're not equal, so we want C. So to summarize here, the idea is that our null hypothesis is that our test claim that diet is less than regular is wrong and that they're actually equal. And our alternative hypothesis is that the test claim is right and that the population 1 is less than population 2. Okay, so then it says to find the test statistic, and it says T is what? So now we're going to need to use these summary results from the samples and do some crunching, which we'll open up StatCrunch for. So in StatCrunch, I want to set up this hypothesis test. And we are making a test about the means of two different populations and the difference between them. And we do not know the standard deviations of those populations, or even that they're equal. That's not to be assumed. So if I go to stat, when I'm testing a mean stat without knowing population standard deviation, that's a t distribution. Now we're clued in this case because in the problem it says find the t statistic. So that tells us it's a t-stat. But if it didn't give you that information, this is a t-statistic distribution because we're testing a mean without knowledge of the population standard deviation, which is the normal way you test a mean. Now we have two samples because we're comparing the two. And they didn't give us all 24 values from the samples. They gave us the summary in a chart. So I'm going to go with summary. So we are doing a t-distribution of 2 samples with a summary of the data results from those samples. So if I click on that, then it wants information. It wants the mean, the standard deviation, and the sample size from each, and then we can go down here and look at the hypothesis test that we're doing. So let me put those values in. So the mean value was 0.79795 for population 1. The standard deviation was 0.00433, and the sample size was 24. And for number 2, it was 0.81917. And of course, if you're doing problems like this in your homework and you make a mistake, no big deal, you can redo it. But if you're taking an exam, you want to be very careful if you actually have to type in values. Double check that they're correct. Like I just put in a 1, for example, 0.00755. That looks correct, and the sample size for the second one is also 24. So I enter in those data results from our samples. So we are performing a hypothesis test, and our null hypothesis was that mu1 was equal to mu2. You can rewrite that equation as the difference between mu1 and mu2 equals 0. If I took the original equation and subtracted mu2 from both sides, it would look like this. That's the way StatCrunch writes it, slightly differently than the way my StatLab writes it, so we have to recognize that's the same. And then similarly, my alternative hypothesis is that mu1 is less than mu2. If I subtracted mu2 from both sides, I would get mu1 minus mu2 is less than 0. That's not the default here, so I need to change this to say less than 0. So that's what we want. If I was doing a confidence interval, I would select that, but we're not. We're doing a t-statistic. So I can hit compute. And there's the info. So it has a bit of a summary here, but in particular, for example, if you needed to know error or degrees of freedom, that's here. But here's our t-stat, which it asks for. So it says it wants the t-statistic rounded to 2 decimals. So if I go to the first 2 decimals, I'm going here. Negative 11.94, and the number after the second decimal is a 4, so I don't need to round up. So let's put that in. Rounded to 2 decimals, that looks right. Okay, it's happy with that. So then it says they want the p-value, which is also here, and that's rounded to 3 decimals. Yes, 3 decimals. And it says it's less than a 1 after 4 decimals. So if I round that to 3 decimals, I just get zeros. But I'm going to copy those 3 decimals and put that in. That looks right. Okay. So that was the test statistics. And now we're supposed to draw a conclusion from that. So what happened? Our null hypothesis was that they're the same, and our alternative hypothesis is that the diet has lighter contents or a lower weight than the regular soda. So this t-statistic gave a p-value of very, very little. So the theme to remember here for hypothesis testing is if the p is low, the null must go. What that means is if the p-value is low enough, below the significance level, then the null value must be rejected. So because our p-value is below the level of 0.01, the significance level, that means we reject the null hypothesis that their weights are the same, and that this provides an evidence in support of the alternate hypothesis, which is that the diet weighs less than the regular. So we want to reject the null. We see fail to reject, no. The p is low, we are going to reject the null. Null must go. So rejecting the null hypothesis is a choice in B and C. So we want to choose one of those. Then in B it says we reject the null and there's not enough evidence. But there is enough evidence because the p is low. So we're going to choose C. The correct choice here is reject the null hypothesis. There is sufficient evidence to support the claim that the cans of diet soda have mean weights that are lower. Okay. So then next up for part B, it says, well, instead of doing a t-stat, we want to do a confidence interval. So, well, we just saw that as an option here. So actually, before, I don't have to enter the data in. I'm going to go into options and I'm going to hit edit. And now I'm going to bring this screen back up, and then I don't have to re-enter the data. Instead of choosing the hypothesis test, I'm going to switch over to a confidence interval. And we have a one-tailed confidence interval at 0.01. So instead of 0.99, I want 0.9. Instead of 0.95, which is the default, I want 0.99 for my confidence interval, because that matches up with a 0.01 significance level. And I'm going to hit compute. So now it gives me the box, but instead of giving me a t-value, it gives me the confidence interval. So let's see, the lower value they want to 3 decimal places, which would be 0.026. And the number after the 6 is a 0, so I don't have to modify it. Let's put that in. And then for the upper confidence level to 3 decimals, 0.016. And again, I don't have to modify it. So that looks right, 0.026, 0.016. These are both negative numbers, so that looks correct. All right, and then it wants us to try to draw a conclusion. Does the confidence interval support the conclusion found with the hypothesis test? So what does the confidence interval show us? That we're 99% sure that the actual difference in the true mean population values is in this range. And since this range is only got negative numbers in it, that suggests that mu1, we're 99% sure, is less than mu2. And that's what our claim was. And that's in support of the hypothesis test conclusion. So I'm going to say yes, because the confidence interval contains only negative values. That's in support. And then that's it for this question. All right, so anyway, so this was an example with lots of parts and good use of StatCrunch of a hypothesis problem for a difference of means from Chapter 9. I hope this helps. Keep up the hard work.